Now we've built a model, we have validated it. Let's go on to the next lesson about under and overfitting, understanding how the complexity of the model is influencing the successful nature of a model. Here I've cloned the notebook so that I can have it in my own Kaggle account, and I can go through each of the sections line by line. You can do the same to follow along. This whole lesson is really about two concepts called underfitting and overfitting that are really important in machine learning. This is a really foundational understanding of how training and testing and evaluating a model works. Let's go back to the really simple example they gave in the beginning where they had these trees where based on the number of, or the levels, the depth of the tree, in this case, there's 3 levels. This makes a more or a less complex model. And so you should ask yourself, how complex should this model be? And that's what underfitting and overfitting actually mean, is that it's basically trying to find the balance between complexity, either not complex enough or too complex in the context of how accurate the model ends up being. Once again, I'm not going to read through all this. There's quite a bit of text here, which gives you a nice understanding. So go ahead and read through that. I'm going to skip right to the definitions of underfitting and overfitting. Basically, underfitting and overfitting are, and you can basically see on this graph, as the tree depth of your model gets bigger, what happens is that your model becomes more complex and is better and better at capturing the complexity and the nuance of your training data. And then on the y-axis, you can see mean average error. So in the very beginning of a very low complex model with not very many levels, you're going to have a high error in both your training and your validation data sets. As you increase the complexity of that model, of course, your training data set is always going to get more and more accurate because your model is finding more and more signal in your training data set. But your validation data set, what's happening as you get more and more complexity, there's a sweet spot where once you hit that point, the model actually, as you add complexity, the validation accuracy gets worse. So why is that happening? It's because your model is learning things about your training data set, which are so detailed and minute and complex that your test data set won't have all of those situations and characteristics. Underfitting is the process of having a model that's not complex enough. Overfitting is having a model that is too complex. And your key point is to minimize this error rate for your validation data set, which means a lot more than your training data set. So we'll go through now through a very simple example where you have the training model from before for this housing data. It's been split into train, test, validation sets for training and validation. Now you basically will run this data set to create a train, test, split. You're going to load all the different attributes. This is all basically the same code as what we looked at in previous lessons. And one of the things that we'll do this time is we will create a for loop, which allows us to automate the process of running and training and validating these models with 4 different input parameters for this model decision tree regressors. The input parameter we're going to specify is the number, basically the leaf nodes. So the kind of the complexity and the depth of the model itself. When we run this, what happens is that basically 5 leaf nodes versus 50 versus 500 versus 5,000, these are all increasing from least to most complexity. 5,000 leaf nodes allows you to have these really big, deep trees. 5 leaf nodes is a very shallow, less complex tree. Your mean absolute error on your validation data set goes from over 340,000 to 240, and then in your most complex back up to 250. So this is a really simple for loop, which is doing somewhat of an optimization. It's not a thorough optimization, but you notice that it is showing you that the most optimal complexity for this problem is around, let's say 5, and out of these 4 options at least is 500 as a parameter for max leaf nodes. So this gives us an understanding of how we can understand that trade-off or that balance between complexity between overfitting and underfitting, where 5 and 50 as options are probably underfitting, 5,000 is overfitting, whereas 500 is the best out of these 4 options. So you can learn more. This is really an important concept. Please try to internalize this conclusion and then try to work on exercises if you'd like to solidify this understanding of what under and overfitting is.